Hey everybody, it's Miss Phoebus, and this is lesson 26, absolute value functions. All right, I taught this lesson in person first period, and I'm sorry that you're having to wait for the video, but I'm going to try to get these done during second period and upload them as soon as possible. So if you go to the page and the video is not there for you, if you can come, maybe go do something and then come back to it later, it should be up at least hopefully before 10 o'clock. I know today is going a little bit long. I was having trouble getting my microphone working. So absolute value functions, here we go. By the end of the lesson, hopefully you can precisely graph absolute value functions and write the equations of the absolute value function from a graph. And these are our standards. We're looking at key features. We're looking at graphing absolute value functions. We're also identifying the effect on a graph, and we're actually going to pull that into an equation ourselves. All right, so analysis of an absolute value. You should know that these guys are V-shaped. Okay, and what we're going to do is we're going to plug in our absolute value. We're going to plug into our function a -6. So the absolute value of -6 is 6, and that corresponds to a point, -6, +6. So there it is, -6, 6. All right, now we're going to do the absolute value of -4, which is 4. So that's another point, -4, 4. And I need it to look V-shaped, so that doesn't look V-shaped yet. So let's plug in absolute value of -2 is 2, so -2, 2. Absolute value of 0 is 0, 0, 0. Absolute value of 2 is 2, so 2, 2. Ooh, we're starting to pick up on our graph. And what we're going to have is we're going to have, absolute value of 4 is 4, we're going to have these absolute value functions, which I know you know are V-shapes, 6, 6. But these are going to be graphed precisely. So I want to see lots of points. I want to see lots of lines with arrows. Okay, and that is our parent function. So it is V-shaped. It has, this is important, this is what we call a vertex. It has a vertex at 0, 0, or the origin. Let's see, what else do we notice? We've got some line symmetry. See that? I can cut this down the middle. So we have some line symmetry, so it's symmetric. And then you should probably look at the slope. I want you to compare the slope on the right versus the slope on the left. So we've got m equals, so on the right we go up 2, right 2, up 2, right 2, 2 over 2 is 1, we've got a slope of 1. On the left we go up 2, left 2, up 2, left 2, that's -2, or up 2 is +2. 2 over -2 is -1. So our arms have opposite slopes. And this will be true for every single value, absolute value function. The arms will have opposite slopes. So if you know the right arm is 2, you know the left arm is -2. If you know the right arm is 1/4, you know the left arm is -1/4. So if you know the slope of one arm, you actually know the slope of both, because you just change it to its opposite. So that is our parent absolute value function. Let's go into a little bit more detail and remember the domain. The domain goes from -infinity to +infinity, and that is true for all absolute value functions. Okay, so that will be true. I said to first period today, I said I could be a little creepy, but I could break into your house at 2:30 in the morning, gently wake you and say, hey, what's the domain of an absolute value function? And you should be able to say in your sleep, -infinity to +infinity. It's true for all absolute value functions. Now the range is going to change. We have a lowest point here at 0, and 0 gets a bracket. We have a highest value of +infinity, and it gets a parenthesis. It has an x-intercept at 0, 0, and a y-intercept at 0, 0 as well. They can be the same. Now, it is possible, let's draw another little absolute value guy. It is possible to never have an x-intercept. this green absolute value function is never going to get anywhere close to the x-axis, so it's not going to have an x-intercept. So you would write none in that case if that question came up. But they should have y, all of them should have y-intercepts. You may just not be able to see it right away. All right, let's look at the idea of max and min. So max is the highest point, a maximum. Min is the lowest point, a minimum. And these are about y values. So in an absolute value, you will have one or the other. You will have, in this one, a minimum, a lowest value. So there's a minimum at 0, 0, or usually it's just a y value of 0. You can have a maximum if you reflect across the x-axis and flip it upside down, you will have a maximum value. But in an absolute value function, you will only have one or the other. It is possible to have a max and a min, but that would not be in an absolute value idea. All right, let's look at reading these. We have intervals of increase or decrease. So remember, we had increase, decrease, and constant in Unit 2. No constant here, no flat horizontal lines. But our intervals of increase or decrease, we start on the left, we read our graph to the right. So if I start at the left, how far, well, actually, I'm coming through and I'm going down, 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 down. That's going to be a decreasing function. So I'm decreasing. Where does it start decreasing? And these are x values. It decreases from negative infinity, and then it stops at 0 and gets a bracket. And then for increasing, because then it turns around at this vertex, remember the vertex? Turns around at the vertex and goes up, 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 so that becomes an increasing function, and it goes from 0, and it increases forever to positive infinity. All right, in behavior is, if I tell you the x direction we're looking, can you tell me where the y direction is headed? So as x goes to negative infinity is to the left. My y values are going to go up to positive infinity. And then as x goes to positive infinity, which is to the right, my y values are headed up to positive infinity. In this case, if I reflected this, they would both be headed down to negative infinity if I reflected over the x-axis. All right, so let's look at the anatomy and absolute value, but I just want to make sure you know absolute value graphs must be graphed precisely, have to be graphed precisely. And so what we're going to be doing here is we are going to be looking at the structure of the equation, and we've already looked at that a little bit, but we're going to just review this. It's really good for test 3, right? So minus h is going to control left or right. Some of you are still confused on this. It's opposite. I see a minus. I usually think left. This is actually going to move me right, h units. If I see a plus, I usually think right, but that's going to move me left, h units. The one outside, the plus k, is going to do up and down. Sorry, lost my train of thought there for a second. Plus k is going to move up. Minus k is going to move down. All right, and then A has 2 jobs. Job number 1 is if it's negative, it's going to do a flip over the x-axis. And then 2 is going to be, it's that vertical stretch and compression. Oops, vertical stretch or compression, but we're going to look at this as the slope of the right arm. So that number is going to tell us the slope, and if it's a number bigger than 1, we're going to see a stretch. If it's a number between 0 and 1, we're going to see that vertical compression. So we've got our parent function, but we're about to deal with a whole bunch of child functions. Are you ready? Remember, the parent function goes through 0, 0. These are not going to go through 0, 0 necessarily. So what we're going to do is we're going to look at the vertex, and the vertex is going to be located at h comma k. What you just wrote down, you're going to look at left or right, hanging out with x. We're going to think opposite, and then we're going to look outside, up and down, and that's going to be, we're going to take whatever sign we have with that. So the vertex, I'm going to look at the x part of my vertex right in here. I'm going to have parentheses, 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 parentheses around points, parentheses around points, parentheses around points. Do you know why I'm saying it so much? Because you haven't been doing it, some of you. All right, so for the x part of my vertex, I take the opposite of, I see a negative 4, that's going to be a positive 4. And then that positive 5 is just going to be my y value. So I'm going to plot that point 4, 5. There it is. All right, now the number in front, and there is no number written right now, but it is understood to be a 1. That is the slope of our right arm. And with slope, if we have a 1, it would be 1 over 1. So I can go from this point up 1, right 1, up 1, right 1. Now, if you're feeling very adventurous, you can go up 2, right 2, because 2 divided by 2 is 1. There is your right arm. But that's not an absolute value v. So we have to remember that the slope of the left arm is going to be the opposite. So we're just going to throw a negative on there, and we're going to go up 1, left 1, up 1, left 1, or you can go up 2, left 2. Connect them. I should see lots of points. Connect them with lines, and then put little arrowheads on the end, and there's your absolute value v. All right, domain. Again, I should be able to talk to you in your sleep. You could even go ahead and fill this one out. Negative infinity, positive infinity. Every single absolute value function, negative infinity to positive infinity in the domain. Range will change. Ooh, that rhymes. All right, for this one, range, the lowest that it goes is 5. And the highest it goes is positive infinity. Now, you can tell this without looking at a graph because this 5 and this 5 are the same 5. So the y part of your vertex is going to either be the lowest point, the minimum, or the highest point, the maximum. Question is, does it open up or does it open down? Oops, does it open down? So if it opens up, the a value is going to be positive. If it opens down, the a value is negative. Well, I can see that there's a 1 here in front. 1's positive, it opens up. So that means that 5 has to be my lowest value. So you can play around with that idea. I think there's some problems in the homework where you have to decide what the domain and the vertex and the range are without graphing them. And so that's one aspect of how to figure out what the range is. So let's look at number 2. We've already figured out the domain. Let's figure out the vertex. So remember, we need points. To find the x part, we're going to look inside with x. We want the opposite. I see plus 2. The opposite is negative 2. I see a minus 3. The opposite is negative 3. Not the opposite. I messed that up. I said it wrong. I wrote it right. I said it wrong. So the opposite of positive 2 with the x is negative 2. I keep the negative 3 that's at the end. That's my y value. Keep it. All right, I'm going to graph that. Negative 2, negative 3. That's down here. All right, my slope is, there's my a value, it's a negative 1. So I'm going to go down 1, right 1, down 1, right 1, or I can go down 2, right 2. I can even go down 3, right 3 if I felt really adventurous about this. Here's my right arm. Now, because that a value is negative, it is opening down. So I'm going to go down 1, left 1, down 1, left 1. This is the slope of positive 1 on the other side. Okay. Now, some people, they start at the vertex and they go up 1, right 1, up 1, right 1, up 1, right 1, and they start building their v that way. But that would create something that's not a function. We don't want to do that. So your v should either open up or open down, not open sideways. All right, range. I go from negative infinity because this has got a negative 1 in front of my absolute value. So because of that, it's going to be flipped upside down. That means that the highest point that I have is negative 3. So I'm going to be looking from negative infinity all the way up to negative 3. And negative 3 gets a bracket. Because I can physically touch it. I can say, look right here. I graphed that point. All right, let's try number 3. Actually, why don't you try numbers 3 and 4. See if you can graph them. Pause the video now. All right, so my vertex is going to be 4, 2, because I have the opposite of -4, and then I take the +2. My domain is negative infinity to positive infinity. I can do that over here. I haven't even done that one yet. Now let's try to do the range because we want to be able to do that without a graph. So because this is a +2, it opens up. So that means that it has a lowest point, and that lowest point, that bottom part of the vertex, the y value is 2. So that means that it's going to go from 2 to positive infinity. See, we didn't even need a graph for that. We just needed to know the ideas behind it, where to look for that stuff. But our graph should support our answer for our range. So if we graph it and they don't agree, one of those has a mistake. So you would need to look at it again. All right, so we're going to go 4, 2. The slope of our right arm is 2. So we're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. There's that one. And then we're going to go up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. There it is. That's our graph. All right, let's look at number 4. Our vertex is -1, 4, because I see a +1, it needs to be a -1 in the parentheses. All right, the range looks like my a value is negative, so that means it's opening down. So that means I'm going from negative infinity all the way up to my vertex, which has a y value of 4, and that gets a bracket. So I'm going to be at -1, 4. I'm going to go down 3, right 1, because that is the number in front of my absolute value bars. Down 3, right 1. Down 3, right 1. And then we're going to go and do the opposite. Down 3, left 1. Down 3, left 1. Here it is, and it should support what I have for my range. It's going from negative infinity all the way up to 4. All right, so here's number 5. 5 is a little bit different. Let's work this one together, and then I'm going to have you work number 6. So the vertex, opposite of -1 is +1. 1, -4. That's down here. And then the domain, negative infinity to positive infinity. All right, this is a +1/2. That means it opens up. That means that the bottom part, the vertex, is the lowest point, and that's going to be -4. It's going to go up to positive infinity. So let's look. Oh, the slope is 1/2, so that's a little bit different. So we're going to do rise over run, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And this is that vertical compression. It looks like absolute value, but it looks like somebody stepped on it. I'm going to go up 1, left 2. Oh no. Hang on a second. Okay, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. There it is. There's my absolute value function. All right, number 6. You pause the video, try to do it by yourself. Okay, you're back. So, -3, -7 is our vertex. -3, -7, right there. Missed it a little bit. Let's try that again. There we go. Domain is negative infinity to positive infinity. This is going to open down because it's negative. That means it goes from negative infinity all the way up to -7. There's my bracket. And then we're going to go build our arm, our right arm. We're going to go down 1, right 3, down 1, right 3, down 1, right 3, as much as you have room for. Down 1, left 3, down 1, left 3. Again, as much as you have room for. All right, how'd it go? Okay, let's look at writing these. So y equals a x minus h plus k. So remember, the minus h controls left and right. The plus k controls up or down. These are individual values. And then the a has 2 jobs. It's either a reflection or a stretch or compression, but we're going to look at this as slope of the right arm. okay, and that's going to help us figure out what number goes in front. But basically, it's identifying these three numbers and plugging them in the right spot. That's it. So from our graph, our vertex is down here at 3, -2. So that's what we're going to write here. We're going to write 3, comma, -2. Remember that this is our h, comma, k that we looked at for our vertex when we were pulling the vertex from the equation. All right, the slope of the right arm looks like I'm going up 2, right 1, so that's going to be a slope of 2. We have 3 pieces of information. We're going to plug them in the right spot. So y equals, the slope of the right arm is a, so 2, absolute value. Now, if you don't have absolute value bars in your equation, that's not going to be a good sign because that means you're changing your function. You have to have absolute value bars. Now, when you, and I think I wrote this in the homework notes, when you go to type the absolute value bar, if you hold shift, to type that, you need to hold shift, and then there's a button right above enter that looks like just a vertical bar. You can use that for your absolute value bars if you haven't found that already. All right, so 2 absolute value bar x. Now, when I go to plug in the x part of my point, I'm going to change it to its opposite. I see a +3. I'm going to write it as a -3. Close up our absolute value bars, and then the k piece just goes tacked onto the end. Now, let's see, it's not going to be the exact same picture, but let's see what the graphing calculator says because we have graphing calculators. Might as well check and make sure we're in the right territory. If you notice, our graph is in quadrant 4, the vertexes, goes up into quadrant 1. So, there we go. We're going to go to y equals. We're going to clear out our functions. That's there. And we're going to start typing in 2. We need our absolute value. So alpha, and then I think it's, there we go, alpha window. There's our absolute value bars. Enter. And then x minus 3. And then we're going to have to hit the arrow to get outside, and then -2. There we go. So let's see, does it match the graph? Looks like we're 3, -2. And then it's hard to see the slope, but you could say, well, 0, 4. Is that on this table? 0, 4. It is. How about 4, 1? 4, not 1, 4, 0. There it is, 4, 0. So you can use the table if the picture doesn't look quite the same. But, well, I guess we're going there. But the graphs are in about the same location, doing the same kind of thing. So you can use your graphing calculator to help you check. All right, let's do domain. So we go left and right forever. So -infinity to +infinity. The lowest that we go is -2, and then we go up to +infinity. All right, let's look at some more examples. But we're pretty much doing the same thing over and over again. So we could go ahead and fill out the domain. I love that part. I think that that's so much fun. It doesn't matter. It's an absolute value. -infinity, +infinity, and the domain. All right, let's identify the vertex. For this one, it looks like -1, 3. The slope of the right arm looks like a +1. Now, when we write this in our equation and you write your +1, you can write a 1 in front. I want to make that different than my absolute value bar. Or you could just leave it where there's no number written in front. That's okay too. X, now I'm going to pull that -1 inside. It's going to change to its opposite, a +1. And then that's a +3. Now you could end up with 0 inside or being added onto the end. 0 is part of your vertex. You don't have to include 0. It's not necessary, but if you want to include it, it's not wrong. All right, the range goes from 3 to +infinity. All right, let's look at number 8, and you can check that if you want to in your graphing calculator. The vertex is at -1, 4. The slope of the right arm looks like it's going down 1, 2, 3, 4, right 1, so that's a slope of -4. So our equation is y equals -4, absolute value, x plus 1 close your absolute value, plus 4. Make sure their absolute value bar is not parentheses. All right, it looks like our range is from negative infinity all the way up to 4, and 4 gets a bracket. All right, here's 10 and 11. Why don't you pause the video, see if you can try them. All right, vertex here looks like it's at 6 comma negative 2. The slope of the right arm looks like it's down 2, right 2. So it looks like a slope of negative 1. So that would mean we would have y equals, now you can write a negative 1. I'm just going to write a negative this time. X, opposite of positive 6 is negative 6, minus 2. And then our domain is from negative infinity to positive infinity. Our range is from negative infinity to negative 2 with a bracket. All right, let's look at number 11. So we've got a vertex at 1 comma 0. The slope of the right arm looks like it's 1. So we've got y equals, you could put a 1 in front. I'm not going to this time. I'm going to have x minus 1. If you have a 1 in front, though, it's not wrong. And you could put a plus 0 at the end. I'm not going to. It's not necessary, but it's not wrong if you have it. It's like a simplified kind of thing, but I'm not going to push that too much. Negative infinity to positive infinity is the domain, and then from 0 to positive infinity is our range. I think we got one more, and then we're done, and I want to tell you about the homework. Oh, no, 2 more. So if you think you can do these, pause the video now. If not, you can hang on just a second. I'll work them out with you. Okay, so our vertex is negative 2, 3. The slope of the right arm looks like it's negative 1. That happens a lot, I guess. So y equals negative absolute value of x plus 2, because it's the opposite, plus 3. The domain is negative infinity to positive infinity. The range is from negative infinity to 3. Here we go. All right, this one has a vertex at negative 2, negative 5. The slope of the right arm is up 1, 2, 3. Looks like it's 3 over 1. I did like a 6 over 2 kind of thing. So I think the slope is 3. So my equation is y equals 3 at absolute value of x plus 2 minus 5, with the domain going from negative infinity to positive infinity, and the range going from negative 5 to positive infinity. All right, if you have any questions, please email me. Let me know what's going on. The other thing about the homework is that instead of turning it in at the end of the week, we're going to do it a little bit differently. You have 10 problems that are already available to you right now. You need to do those and then submit those before 2:45 p.m. tomorrow. So you have all day today and all the school day tomorrow. At the end of the school day, 2:45, those need to be turned in. I think people are waiting until the bitter end, doing 50 problems all at once and basically killing themselves, and I don't think that that's going to help you learn the material. It's also going to help you be able to make sure you got this before test 3, which is tomorrow, ladies and gentlemen. Tomorrow is test 3. So let me know if you need to switch times at all. I need to know that today. Also, you have a thing to read before test 3. If you try to read it after test 3, there is no point in doing that because test 3 is already over and done. Do it beforehand. It will close before you take your test. So don't wait and tell me later on, oh, I didn't do it. It's there for you to read beforehand so that you understand what is expected of you. All right, I will see you in the next video, or I will see you on Thursday. We'll see. All right, bye guys.